Hi, welcome to STEAM Kids Virtual Classroom at the Colorado Model Railroad Museum. I'm Michelle Kempema, the Executive Director here, and with me I have Peter Romero, local science geek. He knows everything about space.
Well, I don't know about everything, but I do like space and planets and all that fun stuff. So we're going to learn a little bit today about Mars and the Perseverance rover, which is on its way there right now.
Yes, right now. So we decided to do this mission to Mars, and we're doing it with NASA. And so we're going to do some activities that go along with what they are doing on their website. They have some really great activities.
Yeah, this information, this coursework comes from JPL, the Jet Propulsion Laboratory in California, and they've put together this whole program. So we're going to just be following along with that program as we go.
Yeah, and we thought we'd try some things just for fun and see how they go, and then you can try them at home too. So we're going to learn a little bit about what is Mars?
Yeah.
What is Mars?
What is Mars?
I have a colored picture of it, and this comes from the coloring sheet that we can give the attachment for. It's pretty fun to color things. There's also Earth, if you wanted to color both planets, as we're comparing Earth and Mars, which is what we're doing today. And so when you download them, they look like this. So you could download both of those and follow along with us. So what is Mars?
Well, Mars is a planet.
It is a planet, yeah.
So in our solar system, we have the sun. We have 8 planets, and Earth is the 3rd planet, and Mars is the 4th planet. So it's just our next door neighbor.
How is it compare in size?
It's about half as big as the Earth in like radius. So just a little bit over half. Actually, I have these little fuzzy balls. So like if this was the Earth, this would be Mars.
Yeah, that's a really good representation.
Yeah.
I like how the Earth is blue and Mars is red. So we always hear about Mars being the red planet. I wonder why we would call it the red planet.
Well, Mars is red, and actually you can see Mars if you go outside tonight. I'm not sure I'm not sure what time or what direction, but I think generally if you go outside sometime in the next few weeks, you'll see Mars in the southern sky, and it does look like a red, kind of orangish red.
I have seen that before.
Star.
It's almost like it flickers red for me or something when I look at it. I see some red in it.
And it has that red color because a lot of the dirt, a lot of the soil on Mars is made of iron oxides. So if you think of a nail rusting, it turns red.
It's that color, that dark red.
That dark kind of orangey, brownish red. And so that's mainly what gives Mars its color.
And we know now because there have been rovers that have gone and taken photos on Mars. So we know for sure that it definitely has that reddish tone. Although they say most of it is a kind of brownish, butterscotchy.
Yeah, and you know what's interesting is if you see pictures that have been taken by the previous rovers on Mars, the sky is pink.
Really?
And the reason the sky is pink is because of the dust from that red soil getting blown up into the air.
Yeah. Let's talk about the atmosphere of Earth versus Mars.
Yeah.
So how are they different?
Well, Earth has a pretty thick atmosphere, and Earth's atmosphere is mostly oxygen and nitrogen, about 80% nitrogen, 20% oxygen. And Mars' atmosphere is mostly just carbon dioxide, and it's very thin.
Very thin.
Very thin.
Yeah.
So if you were standing on Mars and there was 100-mile-an-hour wind blowing, you might not even feel it.
Because there's not enough pushing against you.
Yeah, the air is so thin that there's just not enough air molecules hitting you to really feel it.
So what does that do to temperature on Mars then?
It's cold.
It's very cold.
Mars is very cold. It's do you know what the temperature is on Mars? I don't actually have that data.
I don't either, but what I read on the NASA website is that it can get into triple-digit negative at night.
Like a negative 100 and below?
Yeah,
Wow.
in the Fahrenheit scale. So
there's no, because Mars is so cold, there's no liquid water on Mars.
Right.
Whatever water there is frozen. It's ice.
Right. And there is evidence there was water, and we'll talk about that in a later episode, but really interesting. I also read on the NASA site, they were saying that if you stood at the equator of Mars, right in the middle, on the warmest day, closest to the sun, it would feel like summer on your feet and winter on your head.
Interesting.
Because it loses its heat so quickly because of so little atmosphere. And so we have to be thankful for our atmosphere here on Earth that keeps us warm in the summer and gives us summer, which is really nice.
On Earth, we have all that water vapor that keeps the solar radiation in and keeps us warm, but it doesn't have that on Mars. So
right. So that's going to be one of the challenges of trying to put humans on Mars.
Absolutely.
And that's one of the purposes of Perseverance, which is what we're celebrating the landing of on February 18th and why we're doing these lessons. Perseverance is going to study Mars to see if humans can inhabit this planet. And so it'll be really interesting to see what kind of scientific experiments they do to to see if humans could survive in some way.
Yeah.
That'd be really interesting. Another thing that I wanted to talk about is, what does the surface of Mars look like?
Well, the surface of Mars is really cratered. It's dry. It doesn't have any oceans. And it's dry, and it just looks like a rocky desert.
Yeah.
And actually, I have a picture here. This is a picture of some of the craters of Mars.
I can see the crater right here.
Yeah. And so it has a lot of like very harsh terrain.
Little craters around here.
There's the one big crater, and then there's all these little tiny craters around it. And so you might ask yourself, why does Mars have so many craters?
Yeah. Why does Mars have so many craters?
Well, mostly they come from asteroids and meteorites and things like that hitting the planet. But a better question, I think, Michelle, is why doesn't Earth have so many craters?
Oh, so one reason Earth doesn't have so many craters is we have more atmosphere, so maybe things burn up much more than they would in the thin atmosphere of Mars. So we have less things that hit our planet, less meteorites.
Less things that get through in the first
place.
place.
So shooting stars we see,
yeah,
those are meteorites burning up in the atmosphere. So that might be one reason.
That's one reason. Another reason is because Earth has a lot of weather. You know, we have this thick atmosphere, so wind, and we have rain and snow, and we have water that freezes and then it melts, and so all these things kind of scour the surface of the Earth. And so if they're erosion, and so when erosion happens, things that were like features, craters and things like that that were rough get smoothed out by all that ice and stuff moving around and plants growing.
Even the craters we do have, we really don't see anymore.
Yeah, a lot of them are gone.
Yeah.
And Mars doesn't have weather like that, and Mars doesn't have plate tectonics like we have, the continents moving around. It doesn't have an ocean, so craters happen and they just stay there.
Oh, that makes sense then.
Yeah.
Now, I heard that Mars had volcanoes at one point.
Yes.
They have some mountainous regions. And they're caused by volcanoes?
Yeah, I've heard that too. I think there's a big mountain volcano on Mars called Olympus Mons, and it's taller than Mount Everest. I don't know by how much.
I think it's like 5 times taller than Mount Everest.
It's big.
And I think what they were explaining about it when I read about it was that because there weren't tectonic plates to move, if you think of the Hawaiian Islands, a volcano came up and made an island, and then the plate moved, and then the volcano came up and another island was made, and as the plate moved, you have more islands. But on Mars, there's no tectonic movement, so the volcano just builds and builds and builds and builds in the same place, and so there's this massive mountain.
Yeah, and another thing is Mars is smaller, so it has less gravity.
Oh yeah,
and so things can get taller before they fall.
That totally makes sense. So their magma would come out and just keep going up. Really interesting how different, but the same physics apply.
Yeah.
In the atmosphere, in our atmosphere. So I love the science of studying.
It's really cool. I enjoy it a lot.
So we're going to do a little experiment about craters and making craters. And so we wanted to go through this experiment with you and talk about kind of what it looks like when a meteor hits the surface and what happens to the underlayers of a surface when a meteor hits them. So
I don't know if you've ever been to Winslow, Arizona.
No. Oh, yes, I have.
There's a meteor crater there.
Oh, I didn't go see that.
It's gigantic. It's like a mile across. It's like just this big scoop taken out of the ground.
Oh, wow.
Yeah.
So you can go visit a crater then.
Yeah.
I've heard of Crater Lake.
I've heard of that too. I've never been there.
I know. We're going to have to go visit these places now. So shall we start making our experiment?
Absolutely.
And this video is also on NASA's site. So if you want to watch theirs, you can too. The same activity. So we're going to just scoop out some flour. Here's a spoon for you. We'll have to take turns scooping in here. And this is just general flour. And spreading it out on our pans. And we're creating the interior surface of a planet. Could be the moon, could be Mars. And maybe you have a favorite planet. Our favorite right now is Mars.
So this is like the under part of the planet.
This is the lower crust of the planet. So that's probably plenty there. You want about 1/2 inch to 1 inch.
Maybe just a little bit more.
Now, so you have your undersurface of a planet.
Just kind of shake that out and then smooth it.
Yep, smooth that down. Then what else do we have underneath the topsoil? We have usually some sort of granite rock, some sedimentary type deposits. Well, since we're using flour, we're going to use sprinkles.
I'm going to use my hand because I don't think this is smooth enough.
And so sprinkles, I'm going to put them in there. This is going to be our sedimentary layer.
Nice.
And when we did geology, we learned all about the rock cycle. And this is the rock cycle via sprinkles. Now, we need to create just a general layer of dirt, our topsoil layer. So what we're going to use for that is cocoa powder.
Oh, fun.
And a
And then
sifter.
later we can throw this in the oven and eat it.
Well, you could eat, yeah, it probably wouldn't taste very good. Just the flour. But the sprinkles would sure taste good. Let me put some more in here and I'll hand this to you.
All right. Cocoa powder.
And you're just going to spread
And this
that
and the
around.
cocoa powder is like the crust
This is the
that
topsoil.
the topsoil that we actually see when we go outside.
This would be the red dirt on Mars, the
Gotcha.
red dust. And there was a rover that left a tire print, so they know there's dust, layers of dust, and like you said, in the atmosphere.
Right.
So I'm just going to cover my topsoil.
Cool. There's my Mars.
There's mine. Let's get this out of the way. Now we need some meteorites. There we go, the surface of a planet. I have a few rocks sticking up, some sprinkles.
And
There's
for
one
meteorites, we're just going to use plain
I'm
old
going to use some rocks.
rocks from the garden.
So now here's where some physics apply. A reaction has an
You were a lot
equal and
cleaner than me.
That's okay.
I really got into it.
So how would a meteor hit the planet? It might fall straight down, might be coming in at an angle. So let's try some different things and see what happens. So
You want to go first?
I'll just grab a couple of meteorites that we found outside. I'm going to do a straight down one. Should we see what happens? Okay, here it comes. Woo!
Wow.
It went deep because it was heavy. I can see some rocks. Do you see how I can see the rocks in there? And it spread out, but it went straight in. So
I'm going to do one where I stand up.
okay, that's probably a good idea.
I'm actually going to drop it from way up here and see.
Let's do that.
Because when a meteorite hits, it's going really,
really
fast.
fast.
And so it like digs out all of that stuff that's under the ground. So here we go.
Oh, look at that.
Oh, neat. So look how it exposed some of the white, some of the flour, and it left this pattern of ejecta of the under parts of the crust. And if you look at the pictures of Mars and the moon, you see the ejecta patterns around the crater. It's the same thing.
Oh yeah, you can absolutely see the pattern of how that came out. Now I'm going to try one on an angle.
Yep.
Like it came in this way. Woo! I hit the other rock out. But that could happen.
Yeah.
Look what happened. Deep crater, ejecta in one direction because all my force was moving this way. So all my force continued to go that way. And he even bounced off the planet and buried the other one.
It's kind of like playing billiards.
Yeah.
Okay, here I go again.
Okay.
I'm going to do a sideways one. Totally missed. One more.
Okay.
I'm not good at this.
You have to go like you're skipping a rack. There you go.
Oh, I hit the other one. One more.
There you
Ooh,
go.
that's a good one.
That was a really good one. Look at the ejecta pattern coming out of that.
Yeah. And so when these meteorites hit the Earth or hit Mars, they expose things that were under the ground. And so sometimes that's how we know about what's under the Earth's crust.
Correct.
When these things get exposed.
All these sprinkles that came out are different kind of rock, different kind of material that can be studied on Mars. And so as the rovers are going around Mars, they're studying the materials that they find.
Right.
Whether it's ejecta or surface rock or,
Magma.
Yeah.
Solidified.
So there you go. A little fun activity about Mars. We're really looking forward to this Perseverance landing in February. And we're going to have some more lessons and some more fun activities to learn about Mars.
Yeah. So we'll see you next time.
Yep. Thanks for joining us.
Thanks.
See ya.